Hello, had many questions from people who came into office hours, and so if you weren't able to come in and wanted to discuss the quiz, then I wanted to provide this video so that you can take a look and compare to your notes. We have two chemical reactions, magnesium reacting with oxygen to make magnesium oxide. Then we have carbon reacting with oxygen gas to make CO2, which has a gaseous product. We're going to use our two methods of keeping track of energy and entropy. See that if we have AA bonds versus AB bonds, that the A bonds will have higher potential energy, be less stable than AB bonds. And then the entropy should track with the phase. Solid will have the least entropy. Gases with the largest number of particles would have the most. Okay, so we make the assignments A versus BB and AB, and we see that the products have AB bonds and the reactants have AA and BB bonds. Automatically, we can assign delta H is less than 0 because the products have less potential energy than the reactants. For entropy, the primary consideration here is phase. So we go solid plus gas to make solid. The products have less entropy, so delta S would be less than 0. Keeping in mind that if the products have less of the substance, it is always negative. So delta H, potential energy, is what we're keeping track of for delta H, and entropy, total number of configurations. Let's take a look at, so we have the same argument for carbon with oxygen, CO2, AB bonds as products, dominant, delta H less than 0, products have less potential energy, delta H is negative. Looking at the primary consideration, we have solid plus gas to make a gas. Same number of gas particles, so we can't use the primary consideration for the assignment of the sign of delta S. We must use the secondary, that O2's entropy is less than CO2's entropy based on mass. So delta S is greater than 0. So when there's the same number of gas particles, we include complexity and mass. So CO2 here is much heavier than O2. So we would pick delta S as greater than 0. That means for R1, the answer is D. And what was not asked for in terms of what happens with R2, but we can assign R2 now, is R2 would be B. It would be exothermic, but delta S is greater than 0. So they're different. They're the same sign of delta H, but they have different delta S's. All right, this question asks about the entropy of products. So we're comparing with Mg oxide. So let's take a look. As we discussed in class, if we're in the same column, meaning they have the same charges here, then entropy tracks with mass. So if everything's the same, just like we saw in the last problem, if everything's the same, then entropy always tracks with mass. In the case where they're different, as we're going across a row, we see that entropy increases as the charge goes down. So we're going aluminum is +3 to magnesium +2, sodium +1. We see here that the entropy for sodium would be the least, and the most, and aluminum would be the least. So in this particular problem, the only answer that has greater entropy than magnesium oxide would be calcium. Beryllium would be less because there would be less particles in the same column. Aluminum would be less because it has higher charge. Calcium would be more because it's farther down on the column and it's heavier. And this question is asked for us to pick which reaction does this potential energy versus S curve represent. So from the first problem, we assigned that R1 is delta H less than 0, delta S less than 0. Generating the potential energy curve for that, we first assign potential energy. We see that the products have less potential energy than the reactants because the sign is negative. We then assign entropy. That means that it's negative, so that means the reactants have higher entropy than the products. So we'd have this curve. Going to R2, we have delta H less than 0, but delta S is greater than 0. If we assign configurations first, just to do something different, we would assign products having the greater entropy and reactants having the least. When we then assign the exothermic behavior of products having lower potential energy than reactants, we have this curve. So looking at the problem with R in the top right, P in the bottom left, that would be characteristic of R1. This question is about the assignment of the change in entropy, or the sign of entropy of R2 is based on what? So looking at the reaction, the primary consideration when we make the evaluation is based on phase. But we see that we have one gas particle making another gas particle. Here we don't even consider the solid at all. One gas particle making one gas particle, we see the same. So we can't use the primary consideration to assign the sign of entropy because they're the same. They're identical from the purpose of phase only. To identify the phase, we must look at the secondary consideration, which is O2 gas going to CO2 gas. Here we do see a change in the entropy of the species. At 32 grams per mole, O2 is going to have less entropy than CO2, which is 44 grams per mole. It's much more complex, much heavier. This has the highest entropy. And we would expect the answer to be B, the complexity and mass of the molecules in the gas phase, and it makes the entropy positive. So for this particular problem, phase cannot assign the sign of delta S. We must use the molecule's mass and complexity. Please make sure you feel comfortable with these problems going into the exam, primarily because we'll be asking many questions based on the correct assignment of delta H and delta S.